Curve with equation y equals f of x is always like positive or zero, so never negative, and for x is greater or equal to a, and the integral for the area is given by this, and this is actually a volume of revolution here. A and b are constants where b is greater than a. We're asked to integrate by substitution and show that we can get from the left-hand side to the right-hand side. Let's do this. So first of all, I'm gonna like expand this bracket, which will leave me with r squared plus 2r times f x minus h plus f x minus h all squared. And therefore pi integrated from a plus h to b plus h Now I can separate this into three different integrals by expanding it. And in the answer, you can kind of see that, yeah, that's what these are all corresponding to. So I'm going to get r squared and then 2r f of x minus h. And finally, f of x minus h all squared. Okay, I'm going to deal with these separately. So this can be I1, this can be I2, and this can be I3. So I1, I can integrate directly. Now remember, r squared is just a constant, so it's going to be pi r squared. I can actually bring out the constant and then integrate, which will leave me with x, and I'll get b plus h, a minus h. So it'd be pi r squared, b plus h minus a minus h. Sorry, that should be a plus. Why did I change it? Which will leave me with pi r squared, b plus h minus a minus h. So I'll just get the b minus a. And I can see I've managed to get this part here. Looking at I2, we've got 2r f x minus h dx. And we're trying to get it in terms of the area. Now, don't forget the area was when we had just the function by itself, no plus h or anything, and we were integrating between b and a. So this kind of gives a good idea for a substitution. Let u equal x minus h. When x is equal to b plus h, u is going to equal b. And when x is equal to a plus h, u is going to equal a. We'll also get that dx by du is just 1. So we won't have to worry too much about that. Therefore, I'm going to get pi, and I'm now integrating with respect to u from a to b of 2r, which is still a constant, but it's going to be f of u d. It's going to be dx by du I'll write that in dx by du, but this thing here is just 1. I can bring this 2r out because it's a constant. You can do that. You can integrate and then times by the constant, or you can have the function times by the constant and integrate. It's the same thing because it's just like a summation. So 2 pi r but this thing is actually the same as a. It doesn't matter that I've got u as the what in terms of. Remember, it's just a dummy variable in some sense because we're then substituting in our limits. So we get 2 pi r a. And finally, I3 was when we have this. Same substitution. So again, it's going to be from a to b, f of u squared du, and this would simply equal v. Therefore, it's this thing here, which I'll call star. Star equals I1 plus I2 plus I3. I1, remember, was pi r squared b minus a. I2 was 2 pi r we took out, and then we times it by a. And I3 was simply v. And that is the result that we're asked for. Okay, a solid start. Let's keep going. We're now given this function. Looks good. And we're also given a graph. We've got some asymptotes, x equals m and x equals n, and we have that it crosses the y-axis at 0p. And we're asked to find p, m, and n. Okay, let's do this. So I'm going to look at p to start with. When x is equal to 0, y will equal 4 plus 2 over root 3. Now cos of 0 is just 1, and sine of 0 is just 0, so it's just 2 over root 3. And actually that's going to be my value for p. P is equal to 4 plus 2 over root 3. Next, I'm going to look at the asymptotes. And the asymptotes are going to occur when the function cannot exist, and that is when the denominator is equal to 0. So root 3 cos x plus sine x must equal 0, which implies that sine x is equal to minus root 3 cos x. Or in fact, if I divide through by minus cos x, I'll get minus tan x. Hold on, I don't want that, do I? I just want to divide through by cos x. I'll get that tan x is equal to minus root 3. Now we're working in radians. We've got tan. And actually, it's tan of pi over 3 is equal to root 3. So here we're going to get x is equal to minus pi over 3 as one possibility. That would be down here. Now remember, we are looking between, oh, we don't have all the information here, don't think. Okay, we don't have full information on all the possible values of x, but I can see that I've um, got a negative solution here. It's going to be this, that's going to be m, and then my next one is going to be the next solution in the positive direction. So m is equal to minus pi over 3. Okay, or x is going to equal minus pi over 3 plus pi, because that is the periodicity of tan. It's going to be up here. The next solution is here. It's a distance of pi. So it's going to be 2 pi over 3. And that's my value for n. Okay, and we are sorted. We're then asked to show that the equation for c can be written in a different form, in a function x minus h. At the moment, I've got cos x and sin x. So what this is really doing is asking me to combine them into a single trig function. Okay, so what do I need to do? I'm going to focus at root 3 cos x plus sin x. And because of the nature, because it wants x minus h, then I'm going to set it equal to r cos x minus h, which is r cos x cos h plus r sin x sin h. This is using addition formulae. I have to go with this. If I tried to go with sine, then it would be sine of x plus h to work, and you can see that they want it as x minus h. Now I can compare coefficients. I've got a cos x and I've got a cos x. So it must be that root 3 is equal to r cos h. And then this is actually a 1, so it must be that 1 is equal to r sine h. We can divide the bottom by the top. So tan h is going to be 1 over root 3, and h is going to be pi over 6. I can square it and add them to get r, so I'll get 3 plus 1 is r squared sine squared h plus cos squared h. Okay, we do this method because this cancels, and therefore r is going to equal 2. So I have to convince myself that I don't get minus 2. I think we always take the positive, essentially. And that means that root 3 cos 8x plus sine x is identical to 2 cos x minus pi over 6. And y is going to equal 4 plus 2 over 2 cos of x minus pi over 6, which I can write as 4 Now these twos are going to cancel, so I'm just going to get sec of x minus pi over 6. That's a much neater way of writing that formula or that function. Now we were asked to specify the function f, so I better do that. F of x is equal to sec x. Also asked to specify the constants r and h. R equals 4 and h equals pi over 6. That's pretty comprehensive. Okay, final part of this question. Let's do this. We're told that the region bounded by C, the x-axis, and the lines x equals pi over 6 and pi over 3 is rotated through 2 pi radians about the x-axis. Find the volume of the solid formed. So the volume is going to be pi times the integral from pi over 6 to pi over 3 of y squared. Remember, we have some sort of function and we're essentially turning it into lots of little infinitesimal cylinders with it will be an area here of pi y squared and a width of dx, and we're summing all of these up. Now in our case we have our function, and what we want to do is not use the original form of the function, which was involving sine x and cos x. Sorry, it's a little while ago, but it was up here. We don't want to be dealing with this and trying to integrate it. We want to use the more simple form, which we found at the end of the last question. So it's going to be 4 plus sec x minus pi over 6 squared dx. Now, you can go ahead and square this and integrate and use these limits, and it will absolutely work fine. But there's a nice little result that we can use from part A. So I'm going to do that because that is the intention of the question. You don't have to do it. It should just speed things up a little bit. So use this. We're going to get, we can see that I've got pi over 3 and pi over 6. So we need to think about what h is, but remember we have it. We have that h is pi over 6. So I've got a minus part here. And that means that b is going to be pi over 3 minus h. So it's going to be pi over 6. And then a plus h is pi over 6. So a is going to equal 0. Therefore, the volume is going to equal pi r squared, pi over 6 minus 0, plus 2 pi r, and then it was the integral from a to b of the function without any, just sec x, and then the volume was pi integrated from 0 to pi over 6 of sec squared x. Now, like I said, I'm just going to say this one more time. You don't have to do this. It just looks a lot nicer than if you start expanding this bracket and having to integrate sec of x minus pi over 6 all squared, etc. Okay, we've already dealt with a lot of the integral from what we did previously. So this is looking a lot nicer. Let's focus at one part at a time. So if I integrate sec x, then I get ln sec x plus tan x evaluated between 0 pi over 6. Okay, so cos pi over 6 is root 3 over 2, so this will be 2 over root 3. And then tan of pi over 6 is 1 over root 3. Then I'm minusing ln of, well, 1 over cos 0 is just 1, and this is going to cancel. So that's going to leave me with ln, it's going to be 3 over root 3, so it's actually ln root 3, which is pretty nice. Now at this point, I've just realized there's one thing I've not done. I've not actually said what r is, and r is equal to 4. So we'll be using that in a minute. And actually, I should have already put it in. This here should be 16 instead of pi r squared, and this should be 8 pi. Okay, I also need to work out the integral from 0 to pi over 6 of sec squared x. And that is actually tan x, which gives me, just like before, 1 over root 3. So therefore, the volume will be 16 pi times pi over 6, which will be, well, 16 over 6 is 8 over 3 pi squared. Then I'm adding 8 pi times ln root 3. Then I've got my pi times my 1 over root 3, which is pi over root 3. That's pretty neat. I think I could just tidy it a little bit more. 8 over 3 pi squared plus 4 pi ln 3 if I bring that half down from the square roots, plus pi over root 3. Okay, really nice integrals once, or relatively nice integrals once we get it in that form from A. So we are done. Well done.